Welcome to Unit 5, all about statistics. Unlike some of the more recent units where we do a lot of heavy algebra and a lot of factoring and canceling and working out large problems, statistics is much more almost like in English or a social studies class, where we're going to look at a problem and try to understand what are some of the major things going on. There's a lot of vocabulary that we're going to be looking at and trying to understand what these words mean to describe different situations. And we're also going to need to do a little bit of number crunching at the right time, but more so interpret what those numbers mean. So this unit is going to be very different than some of the other ones that we've been doing recently because it's on a totally different topic within math, which is stats. This first part we're going to talk about gathering data. So all about understanding how we would collect information, why we would collect information, and what are some different valid ways of doing that. First section is defining a population of interest, collecting data, and avoiding biased data. Our vocabulary, we start out with a population. Now, we usually think of a population as how many people are living here. For example, the population of the Earth might be 7 billion, or the population of Byron might be 5,000. But when we think about it in statistics, we're trying to be a little bit more general than that. It's the group of individuals that we want information about. So if I'm doing a study about students at Byron High School, the population is students at Byron High School. If I'm doing a study on professional baseball players, then the population is professional baseball players. And the reason we define it this way is if we're doing that study on these professional baseball players, we don't want to collect information from stay-at-home moms. We want to find professional baseball players to have in our study. Second thing on our vocab is measurement error. It's being realistic about the fact that even though in the math world numbers can be perfectly exact, when we go out in the real world and measure things, let's say we collect your 40-yard dash time or we measure your height, the measurement tools are not perfect, and the humans that do the measurements are not perfect. So the data they produce are not going to be perfect. So measurement error is the fact that when we measure things, it's not going to be mathematically perfectly precise. There's going to be a little bit of error. Next thing is a survey. Most of you have taken plenty of surveys in your life. It's just a set of questions that different individuals will answer. So you're given a list of questions and you respond to it. Bias data is data that does not represent the true population. So imagine that you're trying to study Byron High School students and you collect data from a specific group. Let's say you only ask the guys for their data. Do you think that will represent the entire population, or do you think that there will be some bias in their result? Well, clearly it's not going to represent everyone. And then finally, a voluntary response. This is when people choose to participate in some sort of survey. For example, if I asked you, all right, well, who would like to take my survey in the class? I put it on our Moodle site, and anyone who is interested can take it. And let's say 5 out of 60 students take it. That would be an example of a voluntary response. People could volunteer to take it, but not a large percentage of the population will actually do it. Let's go into some examples and see if we can figure out what's going on here. We want to study the 40-yard dash times of high school football players in Minnesota. So what is the population? It's high school football players, and specifically in Minnesota. The population is very specific to who you are trying to study. How would you collect the data? And would everyone participate? And would there be any error or bias? This is going to require a little bit more thought. There's no mathematically exact answer to do this. But if you're trying to collect data on high school football players in Minnesota, you might, and specifically 40-yard dash times, maybe you want to set up some sort of spreadsheet online where different coaches can report their team's 40-yard dash times. Or maybe you don't trust the coaches because you think that there would be some bias. You think the coaches might lie about their students' 40-yard dash times. So maybe you send people out from some state organization to different corners of the state to collect a small sample, only a few people from each team. And if they did that, well, then maybe everyone wouldn't participate. But there might be less error or less bias. How do you decide what day to collect it on? Is it right after they played a game and maybe are exhausted? Do you do it in the morning or at night? Do you give them time to rest, maybe between running it a couple times? So there's lots of things when you're running a study to think about in order to determine how fair or unbiased it's going to be. So there's no really right or wrong answer. All the things I just said, you could write any of those down here, and any of that would be correct. It's the process of thinking about, well, if we're going to study high school football players in Minnesota, we need to somehow collect information from them. And that's usually going to be a messy process. Next example, we want to study how many times BHS students cheat in each school year. If we want to study how often they cheat, but our population is the people we're studying, we're first going to say we're studying BHS students. That's the who. So who is Byron High School students. We want to study how many times they cheat in a school year. How would you collect that information? Would you send out a survey and say, how many times have you cheated this year? Do you think people would be honest with their results? It would be hard to know how good the information is that you collect. Maybe you send it out to teachers. You say, how many times have you seen students cheat? Well, in that case, the teachers might think a student's cheating, but they're not. Or maybe they didn't see or catch students cheating very often, so maybe the reported information would be too low. Especially when you have a situation like this where you're trying to measure things like cheating, where students are less likely to tell the truth and teachers are less likely to necessarily know, there's going to be a lot of bias and error. So yes, absolutely. There's going to be plenty of bias, plenty of error. Could you get everyone to participate in this survey? Probably. You could ask the entire school to participate. You could have them all do it during some period of the day. But how good would their data be? Probably not very good. Last example, 1,200 adult Americans are asked, in light of a huge national deficit, should the government spend additional money to establish a national system of health care? 39% of those responding answered yes. Well, what kind of bias are we looking at? We have all these Americans, and it says, in light of the huge national deficit. Then it asks, should the government spend additional money? When you start out your question with some kind of phrase like this, imagine if I said, given that algebra is the worst class in the world, how do you feel about changing math curriculum? Well, you think you're going to answer differently than if I said, given that algebra opens lots of doors to opportunity in your life, it completely biases how the person is going to respond. It makes them think about something differently before they give their answer. So what kind of bias might there be? We would call that wording bias, or something similar to that. There is bias in how we phrase what we're doing here. So when you're giving a survey, you have to look at who you're giving it to. You have to look at how you word the questions, how you collect the data, who's going to actually participate, if it's going to be everyone in your population or only a part of it, and then trying to make it as balanced as possible.